Digital consumer behavior is volatile. Strategists are chasing target audiences across ecosystems that evolve daily, shifting between platforms and trends. Engineers are tasked with figuring out how to codify that behavior into executing logic. Take live streaming e-commerce. In markets like China, over 200 million viewers watch live broadcasts nightly on platforms like Douyin, generating an estimated $5 billion in revenue. At the same time, brands are deploying experimental Web3 initiatives to capture Gen Z. When Travis Scott held a virtual concert in Fortnite, it drew 12.3 million concurrent players into a single digital space. High-fashion houses like Balenciaga are bypassing traditional media entirely to launch seasonal collections through standalone video games and virtual runways. These decentralized mobile-first social behaviors dictate where the attention is. Brands have to adapt their targeting to follow these fluid, unconstrained environments. While marketing strategists can storm highly adaptive campaigns for these spaces, engineers have to figure out how to translate those chaotic user habits into the rigid, unforgiving state machines of programmatic APIs. Strategists map these emerging behaviors using the PESTEL framework. This matrix categorizes the political, economic, social, technological, environmental, and legal vectors that define a target market. But identifying an audience is useless if your infrastructure cannot completely deliver the payload. The fluidity of PESTEL has to collide with the structural reality of the Google Display and DV360 REST API. The DV360 API acts as the translation layer. It forces high-level strategy to convert into hierarchical JSON payloads and strictly defined targeting parameters. If an engineering team fails to accurately map strategic demands to the API's constraints, the result is active serving errors, brand safety violations, and rapid, large-scale, wasted spend. Executing modern digital strategy requires knowing exactly how the DV360 API manages resource inheritance rules, concurrency limits, and audience data architecture. The legal and political vectors of PESTEL identify risks like regional e-commerce laws or tax compliance. The API translates those risks into absolute global brand safety protocols. This chart maps the resource hierarchy: partner, advertiser, line item, ad group. Partners have no parents. Brand safety rules applied here push downward via targeting inheritance. Inherited targeting cannot be removed at the child level. You can only update it where originally assigned. The API also dictates implicit safety defaults. If a line item doesn't specify an authorized seller status targeting option, the system defaults to serving ads only to authorized direct sellers and resellers. Inheritance is an architectural safeguard. It ensures localized API calls to a line item never override macro-level rules established at the partner level. When social or economic triggers demand a campaign pivot, teams often attempt to rapidly update multiple settings on their active line items. The API enforces strict concurrency control. Simultaneous patch requests updating targeting on the same line item will critically fail. To resolve this, handle requests sequentially waiting for responses, or utilize the bulk edit assign targeting options method to process multiple changes simultaneously. Even when requests succeed, the state of the targeting data itself is volatile. Assigned targeting option IDs are not permanent and can be deprecated by the platform at any time. Deprecated IDs do not stop an active ad from serving, but they cause future retrieval or assignment requests to fail. Engineering pipelines have to actively cache IDs and regularly pull the targeting options.get endpoint to verify support. Managing state in DV360 means treating targeting data as a highly volatile, strictly queued pipeline rather than a static database. Technological and social shifts, specifically the evolution of data privacy laws and Gen Z's shifting media habits, directly impact the API's audience architecture. This illustrates the 4 audience types accepted by the API: Google, first-party, custom, and combined audiences, all feeding into a single targeting type audience group as privacy standards shift. Targeting options deprecate, for example. Extended demographic audiences are no longer fully supported and cannot be assigned. A much larger infrastructure migration is happening with first-party data, specifically around customer match workflows. Engineers are explicitly advised against building new customer match pipelines using the DV360 API. They are required to upgrade to the Specialized Data Manager API to handle these specific audience uploads. Resilient API architecture anticipates deprecation. Surviving ongoing technological shifts requires engineering teams to decouple their audience logic from legacy endpoints. There is one major structural exception in the DV360 API that breaks standard state reading rules: YouTube and partners' resources. YouTube resources inherit targeting from their parent advertiser, exactly like standard resources, but they hide this data from the developer. A standard GET request will return an incomplete view of the true targeting state. Furthermore, you cannot use the API to create or update YouTube and partners targeting directly. It is read only to know and add true targeting constraints. Developers manually query the advertiser, the line item, and the ad group independently and merge those payloads client-side. Assuming a single API GET request returns the full truth of a resource will cause targeting misalignments when deploying campaigns across complex video inventory. The modern digital frontier, spanning live streams, virtual events, and highly fragmented attention, demands agile strategic models. But the programmatic infrastructure used to execute that strategy cannot be agile. It must be rigorous, hierarchical, and fiercely protective of brand safety. Bridging the gap between the two requires three structural pillars: mastering immutable resource inheritance, managing strict concurrency limits via queued bulk edits, and continuously monitoring for audience data deprecations. By treating the DV360 API as a rigid structural environment, engineering teams can build resilient pipelines capable of executing fluid, highly complex marketing strategies without breaking platform compliance.